Hello everyone and welcome to day 3 of our How to be a Data Scientist Python 101 course. Today we're going to be getting a bit braver in terms of how we're using Python for data analysis. So first, Simon is going to be talking briefly about bivariate analysis, and that's when you look at two variables and see if there's a relationship between them. He's going to use some fun data sets to explain how this type of analysis can help you use your data to tell a story. Then Stephen is going to go through our third Jupyter notebook and explain how such analysis can be used to interpret results from the dataset that we provided for you. And he's also going to be explaining the process of cleaning data. Now, this is a really important step in making sure Python can analyze any data properly. As always, you can take this at your own pace. If you need to pause or rewind any of this to make sure you understand it or to look something over in your workbook, that's completely fine. We're also going to be taking a look at the comments on this video, so if you have any questions or if you have anything that sparks your curiosity, feel free to comment under this video. So for now, here's Simon.
So in day 2 of your course, you've been looking at how we can analyse data, with the fundamental first question being, is the data categorical or scale? Because that will determine the type of analysis that you will be carrying out. So if you're working with a scale variable or a numeric variable, you will be looking at things like averages, the standard deviation, the minimum and the maximum. And if you're going to visualise that data to enhance your story more, you will then use a histogram. However, when working with categorical data, you might work with the actual number, you might work with the percentages, you might even visualize that with a pie chart or a bar chart, depending on the narrative that you're trying to tell. All of the types of analysis that you've done, that is all regarded as univariate analysis when analyzing data. Univariate is a fancy word for one variable, uni being one, variate being the variables or the number of variables. So you've been looking at how to analyze one variable at a time, and of course you determine the type of analysis based on the type of data you're working with. What I'm going to talk to you about now, which brings you on to day 3 of Python, is bivariate analysis, which is two variables. Bivariate analysis is where you can really dig into a data set and really start to tell a more in-depth story, because what you can do is look at two variables at the same time and look at how a particular type of person or a particular group of people have answered a particular question or behaved in a particular way. Let's look at an example here. So what we have is a question: who washes their hands more, males or females? So there's two variables going on to be looked at here. There is, of course, gender, which is when we're comparing males or females, or sex or gender at birth. And then we have another variable, which is whether or not the respondent has washed their hands. So what we have is some real data here. We're comparing people with their biological sex or the gender assigned at birth, and we're looking at whether or not they washed their hands after visiting the restroom. So what you can see here is yes, and we've got 57%, and then yes at 76%. So looking at the symbols on the left-hand side, what you can now see is that when it came to men, 57% of them said yes to washing their hands after using the restroom. So think about that 57% for a second. Are you surprised by that? Is that what you would think typically of men? When going to the restroom, do you think that just over half of them would wash their hands? I think that's quite low. I feel quite ashamed by that. Women, we typically expect women to wash their hands more, and as you can see, as according to this data set, that appears to be the case. We've reported 76% of women saying yes to washing their hands every time after using the restroom. So what do you think to that 76%? Does that actually surprise you? Is that what you expected? Because it's basically 3 in 4 women. So if you've got a group of women, 4 of them at a time, at least one of those women hasn't washed their hands. Let's have a look at no, because no can give a different narrative. 43% of men don't wash their hands after using the restroom. That's almost half. Almost half of men aren't washing their hands after going to the toilet. Look at women, 25%. Now this is something that we often do to try and catch out our students, but it's not actually 25%, it's 24%. But you should have a look at the data that's been reported in some of the articles that we might have referred to, and how data can be misconstructed and misrepresented. But the fact of the matter is what we have here is just an example of bivariate analysis, comparing men and women and whether or not they wash their hands, and how that might make you feel in a particular way. So I think this is a good example of how percentages can tell stories, and a good example of how data analysis can make you feel in a particular way. So why don't you have a go now at day 3 Titanic and do some bivariate analysis yourself?
Good day everyone, so my name's Stephen Lynch. I'm here to teach day 3 of the Python for Data Science course. I've been at MMU now for nearly 32 years. I'm in the mathematics and computing department and I'm a mathematician. So I'm going to be showing you how to work with data, and in particular we're going to be looking at data from the sinking of the Titanic, and I'm going to be showing you how you can clean the data. And in the real world, data scientists can spend about 90% of the time cleaning data. So it's very important to know how to clean data before we work with the data and get some results with that. I'm also a researcher. I do research in dynamical systems and chaos. More recently, I'm starting to look at artificial intelligence, machine learning, etc. So I've just written a book which will accompany a RISE workshop entitled Python for Scientific Computing and TensorFlow for Artificial Intelligence, and that will be available in May 2023. And the book will be published early in May 2023, and it's published by CRC Press. Okay, so this is the Python notebook for day 3. I've given it a title Python for Data Science Day 3. If you like, you can edit this. If you just double click on that, you can change the name and call this file, the notebook, whatever you like. So these are called cells. We're on day 3 here, and you can see we use a hash symbol to get a title. To execute the cell, we simply hit Shift Return. So Shift Return executes the cell. So we're going to be looking at the sinking of the Titanic. So there's some information here about in 1912 when the Titanic sank, and you'll see that 1,502 people died out of 2,224. So a typical question with data science is, can you predict can you build a model that answers the question, what sorts of people were more likely to survive with the sinking of the Titanic? So you can see here we've got 4 hidden cells. So we've imported here a picture of the Titanic. If you want to work with your own files, you can see here there's a folder here. If you click on this folder, you can simply drag and drop your files into this folder. So for example, figures or data. So if you're working with your own data, you can simply click and drag your own data into this folder, and then you can import that file into your notebook. Okay, so here we've imported a picture of the Titanic. Okay, so to import data, we usually import data in the form of a comma-separated value file. So that's normally enabled as a CSV file, or we can have a text file, which usually ends in .txt, or we can work with Excel files, which usually end in .xlsx. Okay, so there are 3 data type files we can work with. We also use a package called pandas in Python. So this enables us to read and manipulate that data. So we use pandas to do that. So you'll see here we've got data equals PD. So PD is the alias for pandas. And we're going to read a CSV file. And we can go to a URL. So we can go to a web page to get the data. And you'll see in this case, the data will be separated by semicolons and a commas. Okay, so quite often we can separate the data with different delimiters. Okay, so now this cell is now what we call a code cell, and the code cell is where we actually compile Python code. So to run the Python code, we can simply hit the little play button that you can see here. So you can see that we import the library pandas as PD. So PD is the alias for pandas. From matplotlib, we're going to import pyplot. So we're going to use the alias PLT, which we usually use to plot figures. And then finally, we're going to import numerical Python, which is NumPy, and we're going to use the alias NP. So this is where we load the data. So if I run this cell, we get a little green tick. That means that the cell is completed successfully. So we've loaded the data, and then the command data.head will give us the first 5 lines of that data. So again, if I run this cell, the data.head, then you can see we've got passenger ID, survived, prices, etc. So this is what the raw data looks like. And quite often, we can't really use the raw data because it's not what we call clean. And this is why I say most data scientists spend 80 to 90% of their time cleaning the data. So we need to clean the data. So one goal here is to ensure that we don't have any missing data or incorrect data can be removed, etc. And there are other ways, and you might like to think about, what ways could the data be corrupted or not clean, etc. Okay, so we're going to look at missing data, etc. So to clean the data, here we're going to first of all look at the information. So this cell has got data.info. So this will just give us information about the data. And the next cell, we want to show the data in graph form, because quite often graphical output will give us more information than just looking at numbers. So we're going to show a histogram of the data, and you can see that, for example, with cabin, it looks like there is a lot of data missing from cabin. When we look at age, there is also data missing from age. Most of the other categories, we look like we've got sufficient data. But there's definitely data missing from age, and there's a lot of data missing from cabin. Okay, so we want to, first of all, drop. So one of the attributes is cabin, but obviously there's a lot of data missing there, so we're just going to simply delete that column. So we will run this cell to drop. So in Python, we use the command drop to drop that column, and then again we can just have a look at the head, have a look at the first 5 columns, and if we scan across, then you can see that the cabin column has been deleted. Next, we want to look at missing data. So you'll notice that in the age column there was some missing data. So quite often what we do is we want to insert new data where the missing data was. So we'll just take the mean. So we take the mean of the age, and wherever the data is missing, we'll just insert new data, which is the mean of the age. And you can see that the mean of the age was 29.69. So what we'll do is wherever the data is missing, we will insert just the mean of the age, and that shouldn't affect, well, it can do, but it shouldn't affect the results too much. So we can replace the data, which we do in this cell. And then we want to see again if that has worked. So we can just run that cell to see if it's worked. And now we need to fill in missing values for the embarked column. So I think we do that one there. And at the end here, we've got what's called new data embarked. And then we've got missing data there, embarked. Okay, so you execute those cells just to show that we've put in the missing data. And then the final part, we want to convert continuous data into categorical data. So we have all this data of the age of the people on the Titanic, and now we want to put them into categories. So we're going to have the categories from age is going to be child, adult, and elder. So those passengers who are aged 0 to 17 will be labelled as child. Those passengers who are aged between 17 to 65 will be labelled adult. And those passengers aged 65 to 99 will be labelled elder. So we have 3 categories. And then we want to know what categories either survived or were killed, when the Titanic sank. And you can see that we had 778 adults, 106 children, and 8 elder. And I think this looks like survival data, okay, because not that many survived when the sinking of the Titanic. If you've found this interesting, then you can have a look at, obviously look at other books. But as I said, I've written a book entitled Python for Scientific Computing and Artificial Intelligence, and I will be running a 5-day intensive workshop in May. So you can follow the link there for the RISE workshop there. And if you want to purchase my book, there is a link here in the notebook. So it's published by CRC Press. I think currently the paperback copy is about £40, but I'm pretty sure there will be an electronic copy which will be about £30. And that book will accompany the RISE workshop, which will run in May.
Hello again, and well done for making it through day 3 of our How to Be a Data Scientist Python 101 course. We hope you've enjoyed it so far. You're free now, if you haven't already, to try out some of the additional exercises that we provided for you and perform some bivariate analysis yourself. We recommend you use the Titanic dataset for this. This is because certain datasets are more likely to need cleaning than others. A lot of datasets based on, for example, sales information are put together based on automatic processes, and they don't usually have a lot of data go missing. Whereas historical datasets, for example, are much more likely to need cleaning, as the collection of information is a lot less reliable and sometimes data gets lost over time. Now, there's a few things that you may want to look out for when completing these exercises. And the first thing is for when you import a dataset. If you're importing using an URL, you have to make sure you're connected to the internet. It may sound obvious, but sometimes obvious is best. These datasets that we've provided for you, they're hosted on online platforms, so they're obviously not going to work if you're not connected to the internet. So the second thing to look out for is to make sure you look at what type of file the data is stored in. So if you're importing a CSV, it's not going to work if you're using the method for an Excel file. And finally, if you are importing a CSV, even though the name stands for comma-separated values, commas don't always separate the values. So it's important to go in and look at what is separating those values. And if it's different to a comma, you can use the set parameter to tell the function that's separating the values. Don't worry about writing this from scratch. We provided this piece of code in the notebook for this broadcast, and we won't judge you if you copy and paste. So if you've not done so already, or if you've had a go and you weren't really happy with the results, you can click over to the workbook and have a go at cleaning and analysing some data. Good luck.